So I'll give you a little bit of background of what we are, what we do. So Aviatrix is not a new company. It has been there for long, and we are considered the leader in the multi-cloud networking and security. So company was actually founded in that cloud. It was born for the cloud and in the cloud. And our objective is to basically provide cloud simplicity and automation with enterprise networking, security, and control. Because oftentimes when customers and enterprises, when they're moving into the cloud, they forget that they need to follow a specific reference point, an architecture approach that is missing in the cloud. Because if you look at the cloud itself, it's very flat out there. The constructs are different from the on-prem. So that was the notion when we founded this company, and it has evolved. We have thousands of deployments across major public cloud. So if you look at the enterprises that are using us today, they are getting serious business outcome from our platform. So they are increasing the efficiency when it comes to deploying and building the networks inside the cloud. In the process, with the automation and all these services that we provide, they're reducing the risk of the deployment. In turn, they're achieving faster compliance and then getting enhanced visibility that they need from the cloud deployment. So we have served a number of enterprise customers. And if you look at this is just a subset of them. And our customers are spread across pretty much all different verticals across the globe. Now, if you look at the software architecture of this platform itself, the controller is the first component that you will see, and that is the brain of the solution, the one I'm highlighting here in number 1. So this controller is available in pretty much all public cloud marketplace. So for example, if you log into AWS, go to the marketplace, search for Aviatrix, you will find the controller there. Now, this controller, like I said, is providing the control plane and also the management plane for the entire cloud or multi-cloud interaction. So the first thing that we do, we actually give our customer a prescriptive approach of building these cloud architecture with a set of reference points. So you see access, core, and application layer. And then on the side, you see security and operation pillars, right? So if you have been in the networking industry, you know that when the data centers were deployed, they followed a specific reference architecture, which is the access, aggregation, and core, right? And this is exactly the same type of approach you need to follow when you are into cloud. Now, once you have deployed this controller is a multilingual device. It understands all the cloud native constructs, so it can talk to the cloud, route table, security group, load balancer, and whatnot, but it also builds a hub and spoke architecture in the cloud. So these red circles you see here, these are Aviatrix gateways. So the one in the middle is the hub gateway or the transit gateway, and then you deploy the spoke gateways into respective VPCs. And this controller also talks to third-party partners or our partners like Checkpoint, where we provide value-added services on top of we are already providing to our enterprises today, right? And then the third piece is the CoPilot. So this is for you to provide extreme visibility and observability for your cloud and multi-cloud deployments. Now, once you have this architecture in place, you can see you can copy, paste, and repeat this architecture across multiple clouds. And once you have this controller, you don't need to deploy this controller in each and every cloud. This single controller, which is highly available, will take care of all your cloud or multi-cloud networking and security needs. The important thing to remember is that this is not a SaaS service. This architecture is yours. So when you deploy the controller and the gateways are actually sitting in your account. And that actually gives a lot of flexibility and ease of deployment to our enterprise customers, because they have this peace of mind that my infrastructure is mine. It's not sitting with someone else's infrastructure, which is the case in a lot of SaaS provider options out there. Everything is could be driven from the Terraform, right? So because the foundation or the approach we took is all automated with the infrastructure code. And then you also have option to deploy things through the UI if you want to. Now, if you look at the enterprise journey, a typical enterprise or a customer would start from a single cloud. Why? Because when you are in the on-prem for a very long time, and if you're going into the cloud, there are too many unknowns. From the outside, it looks a very rosy picture. Cloud is just a simple button. But when you start peeking into it, you realize that there are so many nuances you need to take care of. Things are different. For example, internet is a prime example where in the on-prem world, you had a proper DMZ, a rack and cage and everything. But in the cloud, the internet's just sitting next to your application, right? So those are the things that they see out there. So when they start building their network in the cloud, they realize that there is no centralized control plane. It's just flat, right? Though these entities are discrete entities. For example, TGW in region 1, you deploy, you configure, and you go to region number 2, you deploy and you configure, but there is no handshake or feedback mechanism between these entities. So that's the missing piece in the cloud. Then they also realize that how do I actually segment things in the cloud? Because when you connect the VPCs, you do native peering and whatnot, it's pretty much any to any. Even if you need to create some segmentation, you are bound to do it manually yourself, which is error prone, as we know that. Then, like I said, the internet is sitting next to you. So the traffic going out, how do I protect the traffic using the Egress FQDN-based control and not simply IP port-based controls? Overlapping IP becomes another problem because the cloud providers, they don't have a notion of supporting overlapping IP. And we know that when you have partners, when you have other entities connecting into your network, they can bring their own subnets. So this could overlap, right? And then the topic that we are discussing here is extremely important, that how do I actually insert these third-party firewalls or next-generation firewall, CloudGuard, into my network? Because I need to provide enhanced security. We all know that security is just not like one size fit all. It is a layered approach you need to follow. So there are security services that we provide, but you need to go a level up and then use CloudGuard to provide enhanced security posture and then threat prevention for your networks. Now, this is the single cloud problem, right? You see a lot there. When you multiply this and when you go into the multiple cloud, it's unmanageable, to be honest. And the problems that I showed you here on the left-hand side are there, but in the multiple cloud, you are dealing with more issues now. For example, how do I maintain this common standard architecture across multiple clouds? Because I don't want to do things differently. Like I don't want to create unicorns here and there. What about the skill set of my employees? Maybe they trained on AWS. Now you're talking about Azure and GCP. They don't know how the networking and security is done there, right? And then onboarding becomes another challenge because there are different ways of doing onboarding in AWS versus Azure. So you need a consistent approach. The high availability and the active nature of the network becomes very important. And then the reality kicks in and they say, okay, oh my God, I now need to provide the business continuity in cloud as well. I need to have a DRS strategy because these cloud providers, they do go down. I need to have a mechanism so I can say that if region 1 is down, I can easily send the traffic back to another cloud or a different region without me intervening and making changes manually there. So the architecture that we propose here does not require the AWS TGW because you know that AWS TGW is only available in AWS. It's not there in Azure or GCP. So and we know pretty much each and every enterprise is a multi-cloud enterprise. So yes, you can actually use TGW, AWS TGW if you want to, or you can actually use Aviatrix Transit Gateway, which we promote and we preach. And then you can also have a hybrid approach. We have customers who can actually connect the AWS TGW here next to Aviatrix Transit Gateway and can have a hybrid approach. That's also possible. But if you are looking for the best in the breed services and the features, then you should consider Aviatrix Transit because this is where we can innovate really fast. We are not dependent on the TGW APIs, and we can give you advanced knobs and control that an enterprise would need. The performance is line rate basically. So when you're connecting cloud to on-prem, we can support 10 gig direct connect or express route with encryption because by default they're not encrypted, right? So that's we can support. And if you have more, we can actually go even further, like 25 gig or even more when you're connecting cloud to on-prem. Inside the cloud, you can achieve up to 75 gig. And in some cases, we have seen in some AWS region, you can go all the way up to 90 gig. All right, so moving on now, let's talk about the specific features and the partnership or the joint solution we have between Aviatrix and Checkpoint. So when it comes to actually building these secure network in the cloud, like I said before, you need the CloudGuard. You need to have next generation firewall inserted into your traffic flows. Now, if you're not using Aviatrix solution, you run into a lot of challenges. The first thing is all manual. You are responsible for configuring the VPC route table or the VNET route table. You need to make sure that you punt the traffic from your source to firewall, and then firewall, you need to program the firewall as well so that you can send it back to the destination. And for the return traffic, you need to maintain the symmetry. So those type of things that you see. Now, if you're using AWS TGW, and if you're building the IPsec tunnel to connect to the CloudGuard, those tunnels are only 1.25 GB. So you might be purchasing or getting a very high throughput CloudGuard, but you won't be able to get the performance out of it. And when it comes to actually deploying in an active fashion, then you have to deal with ECMP, BGP, then it gets very complicated. And the visibility becomes another issue, because in order for you to pin the traffic to avoid the asymmetry, you're using SourceNet maybe, right? Then you lose the visibility. So these are the challenges that you see if you're not using the Aviatrix solution for your CloudGuard. And then the policy-based control and the management becomes very important, because you have to have a policy saying that this VPC or VNet needs inspection. Only this VPC needs inspection through the CloudGuard, but rest are not. Maybe they are dev or non-important workload. But if you're not using Aviatrix, there is no policy-based mechanism to do that. So we actually provide you the active deployment of CloudGuard in a centralized location, as you see here. There is no BGP, no SourceNet required. We not only provide you policy-based routing and then the control, but also maintain the life cycle of these CloudGuards. So you can log into the controller and you can deploy CloudGuard directly from the controller. We know the health of these devices or virtual machine. We have vendor integration where we can exactly see what's going on with the interfaces. We can program the routes if you're receiving new routes from the on-prem via BGP. And then there are other options available. For example, you can select, exclude some seeders from your security posture, right? And this solution that you see here takes care of all the traffic types. Could be east-west, could be egress, ingress, or going towards on-prem, completely automated. And that's how we do it in one cloud, right? But that's the beauty I was talking about. If you have Azure or GCP, this stays the same. You're not worrying about dealing with the routing there, because in GCP, if you go there, they have a global VPC, shared VPC, they use network tags, they have a firewall rule instead of security groups. The routing table is completely, one big route table. It's not like AWS. So we know all these details, and that's how we program it, and we can give you the seamless experience across multiple clouds. So we'll go a little bit deeper here, and I'll talk about the packet walk for the east-west traffic flows. So in our topology, if you see on the right-hand side, we have spoke A, spoke B. And then in the middle, you see we have Aviatrix transit gateways or FireNet gateways, and then the CloudGuards deployed here. So our objective is to create a policy so that when the traffic is going towards this VPC or VNet, it's being inspected by the CloudGuard. So you log into the controller or you use Terraform, you specify your intent, and then we will take care of all the routing, right? So in our case, this is our 1.10 source going to 2.20 destination. We will program all the routes. The traffic will go to the spoke gateway. The spoke gateway, if you notice, it has connectivity back to transit using multiple paths. Because when we build this infrastructure or this network, we take care of the high availability, right? So this is called active mesh. And when we are building this, by default, everything is also encrypted. Because if you're using AWS TGW, the VPC to the TGW attachment is not encrypted, for example. But we have it as part of our architecture, right? So the spoke gateway will then send it to the transit gateway based on your policy you configured, because we know that you need to send it to CloudGuard. Now, when this transit gateway sees that, it will check the policy-based rule, and then we'll say, okay, I need to send it to this guy. I don't just need to directly route it to this destination B. So this is going to go to CloudGuard. It will do its magic. And if the traffic is good, then it's going to send it back to the transit gateway. Now, this time transit gateway knows that this is a traffic coming from CloudGuard, and it has to go to this destination B. So it's gonna send it there, right? Again, it will have multiple paths to get there. So it will pick one of the path based on the hashing algorithm, and will land into the spoke gateway. Now, a spoke gateway will just hand it off to the native VPC or VNET route table or UDR, and then this will actually deliver the packet to the destination, right? Now, what's going to happen for the return traffic? Now, the return traffic will go back to the spoke, then it will send it to the transit. Now, this transit gateway knows where this packet came from. So it will send it to the same CloudGuard to maintain the symmetry. The CloudGuard will take it, will send it back, and then traffic will go back to the source, 1.10 in our case, okay? So, yes.
Oh, I thought you were going to go on. I've got two questions. I'll wait till you're done, but I've got a few questions coming up. Is it fair to say that we can eliminate the need for BGP completely using the Aviatrix checkpoint combo?
Yes, that is true. Yep, absolutely. If you look at this, there is no BGP running in this case.
And in this context, right? Essentially, I mean, we're replacing the internal external load balancers, right? Not the need for those, right? Because basically we'll just be modifying or adding UDRs, right?
Yes. In this case, this is what we are doing here. In case of Azure, we take care of the UDR programming in the spoke and in the transit or in this hub location. And yeah, that's how we do it actually. Okay, so we discussed this design pattern or the flow where I showed you the east-west packet walk. Now you notice this is a collapsed model where this centralized VPC or VNet is taking care of all the traffic needs, east-west, north-south, or ingress, egress. Now, within the Ingress design, we have two important designs that we want to talk about. So on the left-hand side, you see the standard collapse design where your Ingress traffic is coming from outside, and it is going directly to CloudGuard, right? So you would have external load balancer that will load balance the traffic between CloudGuards, and then this CloudGuard will send it to the transit gateway here, the Aviatrix transit gateway, and then it's going to send it to the spoke, and then you will deliver this traffic over there. So this is very standard practice. But now what I have seen, some customers actually are leaning towards this model on the right-hand side, because if you notice, in this case, the traffic coming in, it's going directly to the CloudGuard. In some situation, you might not want that. You want this traffic to come and hit spoke VPC first. And why? Because you might want to treat this traffic as east-west traffic. Okay, so and you might want to do something on this Ingress spoke VPC. I have seen customers deploy F5, where they can route the traffic based on the different service that the traffic needs to talk to. And that's very common in case of Kubernetes deployment or container-based deployment, where you have xyz.com service 1 on one URL, xyz.com service 2 on a different URL, and you want to treat that traffic differently, right? So if you have that type of requirement, then this model works really well, because you can bring the traffic here. You can have the policy saying anything that is coming from outside is inspected by the firewall for the ingress traffic. The spoke will take the traffic, will send the traffic out to the transit gateway. Transit gateway will send it to the CloudGuard, and then the CloudGuard will send the traffic back to transit, and then the transit knows where it needs to go, so it will deliver it to the workload VPC. So basically, the main point to take away here is that if you have a certain template that you're following, if you're deploying your CloudGuard that way, we can actually ingest that as well. So the controller can actually say that, okay, this is already deployed. I will just attach it to my network. So we will not touch or destroy or delete whatever you have done or what your intention is. But if there are some corner cases, there are specific cases, I think we should talk, and then we can go more into the details of how you want to do it, where exactly this external load balancer you're talking about is for the, this type of Ingress flow, or maybe a different design you're trying to follow. But yeah, so pretty much, all the different cases or the use cases out there, we can support easily. Okay, so this is a different model. So I showed you the collapse design. So this is a little bit different than the collapse design. So a lot of time, what happens that customers, when they're deploying it in a very large enterprise situations, they have different teams managing the east-west set of firewalls versus the egress set of firewall. And we saw that design pattern quite a lot. So we said, okay, why not make it part of the architecture, make it like out of the box deployment. So this is exactly what you see here. In this case, you have east-west set of FireNets or the CloudGuards deployed here. But for the egress, you have a dedicated place, right? And then the controller or Aviatrix is context aware. So what it does, it knows that if the traffic needs to go out towards the internet, I'm going to send this traffic from this spoke to this guy and not to this guy. But for the east-west traffic, I'm going to go send it there and then get the inspection done by the CloudGuard, right? So just wanted to highlight again, like I said before, there are different ways you can skin this, and it's very flexible. You know, when you look at this Aviatrix and CloudGuard together, we provide you all the flexibility that you would need. And this is what I was mentioning before. Like if you're going with the TGW option, AWS TGW or native option, you will not get that, right? And then you are basically, your hands are tied. You're limited by the feature set that they provide you. But if you're working with us, then we can, maybe if there is a need, we can enable certain feature for you. If you need some feature that you want, we can enable it for you or for your deployments.
And Shahzad, I've got a couple questions I wanted to ask.
Sure.
Does the solution, I'm assuming it supports SD-WAN technologies. Can you maybe elaborate a little bit on some of the other SD-WAN technologies or any comments you may have around those?
Yeah, absolutely. Exactly. So in this diagram, what you see is exactly the case where if you look at the architecture that I mentioned before, the cloud core, the cloud access and cloud apps, and then security and operation pillars. So if you look at SD-WAN devices, they fall into the access layer, because what they're doing, they're providing connectivity from on-prem into the cloud. And the thing is that these SD-WAN players, they're also calling them multi-cloud, but the multi-cloud word itself is being used a lot. So when someone is saying multi-cloud, you really need to ask, what exactly are you talking about? Is it the multi-cloud connectivity that you're talking about, which is this SD-WAN guys are doing, or you're talking about the multi-cloud networking and security in the cloud? This is where Aviatrix plays. This is where we have our strength, right? But obviously, we do support the on-prem connectivity because these guys are there. They're going to be there for quite some time. So we do support the SD-WAN. We support the extranets. We support the branches. We also support the user. We have a user VPN solution as well, which is a SAML-based user VPN that allows your customers to connect to your workload if that's a use case you have. So yeah, so these SD-WAN providers are supported. If you look at Viptela, VeloCloud, Silver Peak, Meraki, if you search on YouTube, Aviatrix Viptela, Aviatrix Meraki, or whatever, you will find the solution or the reference design out there. Yeah, the policy of the CloudGuard itself is not managed from the controller. And this is the decision we took while working with Checkpoint and other vendors, that when you look at the teams, the way they are structured, there is a very specific team that takes care of the policy of the CloudGuard itself. And that's a very sensitive thing. It goes through a lot of approval process and whatnot. So we decided not to do that. Although we can easily do that because we have the API integration with the CloudGuard. We know exactly what needs to be done, what is there, the interface and the route and whatnot. But we said, no, we're not going to do that. We will let it handled by the cloud security teams. So for the security manager, we don't directly talk to the security manager, but we can push the scripts into the gateway itself that can program the security gateway in a way that it can actually connect to the security manager, but we don't directly talk to the security manager.
Yep. Okay. Yeah. Perfect.
Cool. Okay, so let's take a look at this this demo really quickly. It's available on YouTube. So what I'm going to do, I'm going to show you centralized deployment using Terraform. So what you see here on this screen is a topology that we will build from our Terraform scripts, right? Because the Aviatrix is the official Terraform provider. You don't need to write the Terraform scripts for different clouds. This is one single entry point for all your automation needs. So what we're going to do, we're going to build this transit VPC with the secure the transit gateways with the CloudGuard. Then we will also build these VNets, and then we'll deploy spoke gateways, and we will also configure the policy so that your traffic is inspected by these CloudGuards. So if I run this, okay, so this is going through the ad now. Sorry about that. So yeah, so if you look at this topology, and then if I move forward, this is my GitHub. So I have this code on GitHub, and you can find a lot of code depending on the deployment that you are pursuing. In this case, the code I'm using is the topology I showed you before. So it's under solutions. You can go take a look at the code yourself. And if I go a little bit forward, you can see my code, which has all the different variables, the account name, the region you want to be in, and then the CDR that you have, what the policy will look like, where exactly you will deploy this, in what kind of region, what the instance size is going to be for this Azure virtual machine and whatnot, right? Now, in my case, I'm using the Terraform Cloud, which is my CI/CD provider. So I actually have this integration between Terraform Cloud to my GitHub. So as soon as I make a change in my code, I upload it to GitHub. The GitHub will talk to the Terraform Cloud and will automatically start provisioning or changing things in my setup, right? So I have all these variables already configured. So what I'm going to do, I'm going to run this manually, right? So I'm going to use the queue plan option. I will queue my plan, and I will say that, yes, this is what I want to do. Now it's going to go check the code and see if everything is good or not. And we'll talk to the backend cloud Terraform. We'll look at the code. We'll say, okay, do you really want to proceed? I say, okay, I want to proceed. So I will just confirm and apply, maybe write some note for my team so that they know exactly who ran it and what the version control was. Now, once I click submit, now it's going to go actually and start creating things for you. So from get-go, like the transit gateway, the VNET, the spoke VNET, the spoke gateways, and then the CloudGuard. So this end-to-end process will take about, I would say, 30 to 40 minutes. Okay, so now my plan is finished. And if I log into my Aviatrix controller, you can see the gateways are deployed, the transit gateway, and then 2 spoke gateways in Azure. And if I go take a look at my dashboard, I can see these resources appeared in my dashboard as well. In the FireNet section, you see 2 firewalls deployed, inspection is enabled. I'm also using it for Egress. So again, that's a single click that you do. You can see the firewall instance, their name, if they're up or not. And if you look at the transit FireNet policy, that's how simple it is. All I'm saying is that these 2 spokes, they need inspection, and they has to go through the checkpoint CloudGuard. Okay. Now, if you look at the firewall itself, this is how it looks like. And like I said before, in step number 7B, if you notice, I'm sorry, it's a little bit blurry here, but you will see all the details that you need for your CloudGuard. And then if you log into the CoPilot, we will show you more. So like I said before, the CloudGuard is providing you the deep visibility and insight into your cloud network. And when you're building it, we are actually building this topology runtime for you and providing all the metadata that you need for your operations team or for you to successfully operate this network. Right? So you're getting a lot more than you actually see even on the Azure console or AWS console, because we are pulling this information from various APIs. Now, if I go back quickly to my slide, what I'm going to show you is actually the demo of CoPilot itself. So, okay, so this is where I am actually logged into my CoPilot. Okay, so when you first log into your CoPilot, you will see, I call it a compliance view. It shows you exactly where your resources are deployed and what kind of resources are out there. Okay, and if these resources are performing properly or not. So if you look at the top, it will show you, I have the user account, I have the BGP connection, it will show you if it is up or not. I have the site to cloud connection, which is about the hybrid connectivity from on-prem to the cloud, if it is up or not, and then a rundown of different gateways and resources. Okay. Now, in the bottom, you see there are different type of gateways I have deployed. So it's your inventory view, your compliance view. If you see something which is suspicious and you believe that this maybe T3 small was not an approved instance, you can quickly go back and see why it happened. And then network traffic is about what kind of traffic is flowing through in and out of my multi-cloud topology. So talking about topology, if you click on the topology view, this is what we are building on the runtime, right? So you can see my topology is very complex, but I can show you the raw topology and how exactly these gateways are connected to and the metadata. And not only that, you can actually troubleshoot directly from this screen. So you can say that I want to troubleshoot diagnostics, and I can see, I can ping, can do trace route, I can test connectivity, I can see the active stateful sessions going through this gateway. I can look at the interface statistics, the Ethernet, raw Ethernet, or if I have IPsec tunnels built to other systems, I can actually see all this detail there. And then obviously this is yours. So you can actually make it yours by changing the physics options and different type of layouts, and you can also save your layout as well. Now, this is a raw topology. If you want to look at it from the Aviatrix transit perspective, we can actually draw it very nicely for you. The latency monitoring is important when you're troubleshooting, and you know if there is a problem between two instances or you're getting report. You can quickly come here, and you can not only look at the live latency information, but also historic information. So you can actually go back in time and figure out why it happened 8:10 a.m. 2 days ago, right? Or if you want to go live, you can actually see the live latency reporting on the screen. Topology replay is extremely powerful. What it does basically is takes a snapshot every minute of your topology, okay? And if something changed, or if you suspect something was different than before, you can actually go back and replay the topology. So in my case, for example, if I click on this guy, it actually shows me that, okay, I have certain changes being made between on March 5th, 2020 at this time. And if I click view, I can see exactly what those changes were. So now it's pulling all the data and it's telling me if those changes were the additions, were some edits, or maybe something went down. So you can actually basically think of it as a diff of your topology. So that's how you can actually call it, and you can specify some node. You have a lot of options. So and it's extremely powerful, like I said. Now flow IQ, what is it? So basically flow IQ means what kind of flows are happening in your multi-cloud network. So we'll give you different options to slice and dice this data or to filter this data. You click on any segment, we will automatically create a filter, and we will redraw everything for you based on this source IP address, for example. So if I clear this, go back to trend is about anomaly detection, right? You can see the spike happened here, for example. Now, if there was an outage or something happened or someone was trying to attack your network, you can go back and quickly narrow down to the issue and saying, okay, this is exactly the time it happened, and these were the possible culprits involved in this spike. Trend is about putting everything is on the map where you can see where your traffic is going to or coming from, and if there are some suspicious countries or places, you can actually go back and then click on the name, and then it will tell you exactly where this traffic was coming from or going towards, right? Flow is about, I call it, top talker view, because oftentimes you want to know who your top talkers are. So maybe you want to bring them close together, because if one talker or one virtual machine is talking to some instance which is sitting in a different region, you might be paying a lot. Maybe there is a potential to bring them closer so that you're not paying that much, and you're optimizing your traffic patterns as well. Or if you look at it from the security point of view, that's the enhancement of your security posture to optimize the traffic or your network. And obviously, in all the cases, you can click and you can create the filter right away, and you can also go back in time. So records is the raw net flow data, right? So oftentimes you might want to go a little bit deeper into what we are providing you out there in these widgets. So if you click here, you have a lot of options, right? A lot of customers, they use this information to identify DDoS type attacks, because this TCP flag or other type of attacks are happening can be easily identified with this technology or with this tool. Performance is about knowing the performance of your gateways, the gateways that you deploy, right? So again, this is a very important piece of information. Cloud routes, in the cloud world, there is no show IP route, first of all, even if you're in the single cloud. And if you're talking about multiple cloud, it's completely a no-no. Now, what we show you all these routes in one single place. And not only the routes from our gateway perspective, but also routes from those VPCs and VNETs. Okay, so we show you that. And then if you have connectivity to on-prem, they will appear in the site to cloud map. And you can see exactly what those routes are and how they are connected, and then what their peer IP information is. Now, the BGP information is very handy, because when you're building these networks, you are talking to the on-prem networks using the BGP. And we can actually show you if the BGP is established, if it is down, and also the map, right? So how exactly my Aviatrix is connected to the on-prem devices and what ASN numbers are. And if I'm learning a route from on-prem, or if I'm sending something to on-prem, you can easily quickly see it here. You can also create notification using email or webhooks, and you can see the notifications going out based on certain threshold I have in my network. So App IQ is about detecting the application performance or connectivity from a source and a destination virtual machine or EC2 perspective. So what you do, you select the source VM, destination VM, you click submit. So when you click submit, this is going to go into the background and will crawl all the information from your cloud, right? So now I can show you exactly the path that this machine took from this source to a destination, right? And then if I scroll down, I will show you all the latencies involved only in this path. Right, so we are actually cutting all the noise. We are showing you this application view, how this application is talking to another application, and then all the memory, and then the performance data, and then the flow data that you would need, and also all the security group, the route table, all the ACLs or whatever you have in the path will show you. And if there is a failure somewhere, we will also tell you exactly where it would fail or could fail. So this is very powerful and handy tool for visualizing your multi-cloud networks. The security is the last piece here. It shows you how these VPCs or VNets are being segmented and what segment is talking to whom. So we'll show you this nice diagram, and then also show you the security domains and how they are connected to each other. Yeah, so basically everything is encapsulated. It's the IPsec standard encapsulation. We are not doing anything non-standard here. So, and then when you're connecting to the on-prem, you have both choices available. So in the on-prem, if you're using your normal Cisco routers or the firewall or whatever, we can run the BGP there. We can build the IPsec tunnel to the on-prem, but the problem is that IPsec tunnel is only 1.25 GB. So let's say if you have purchased Direct Connect, which is 10 gig, and if you try to encrypt it, you're not going to get full throughput or line rate throughput there. So how do you tackle that? So the way to tackle is to deploy Aviatrix appliance in your data center. Okay, so it comes in two form factor. You can deploy as a bare metal. So that's appliance that we will ship, and just a plug and play appliance. You plug it into your data center, and it will automatically build a tunnel back to the Aviatrix transit gateway and provide you encryption there. Or you can go with the virtual form factor option as well. So what you see on the screen is the way to start. So if you just want to kick some tires, if you want to deploy it yourself, you can go to this community page, and we have a very cookie cutter way of deploying it, where you launch this browser-based tool, you provide your AWS credentials, and you click next. And then when you click next, it's going to deploy the controller, it's going to deploy the transit gateway, spoke gateway, it will build the topology for you. And then you can use the Terraform script I mentioned before to actually deploy the CloudGuards automatically if you want to, or you can log into the console at that point and you can quickly deploy. If you need any help, you can email me I can actually help you. I can help you set up the account as well if that's what you're looking for. The demo account or the trial account, we can actually provide you that, no problem at all. To a lot of customers, they have already started the journey in the cloud because their DevOps team took charge and they deployed things in there. So we see this case a lot every day. So if you are that type of a customer, if you're looking to migrate or if you want to enhance your security posture or your cloud network, we have all these use cases taken care of. The platform itself is catered for both greenfield and brownfield needs. So like I said before, if you already have the CloudGuard deploys, we can easily attach it, ingest it. If you have VPCs, VNETs, TGW, we already deployed it. We can easily insert this Aviatrix architecture with CloudGuard in place to provide you this functionality that you need. So it's not a problem at all. If you are in good hands, we have the talent and the experience that we can utilize for your use case. So please come talk to us. Okay, so yeah, so this is what I would like to end with is this call to action. Go there to the community site, try to deploy yourself. Sometimes seeing is important, touching and feeling it is important. If you want to have a customized session with us, please do reach out to us. We can have one-on-one discussion with you. And the last but not the least is the certification that we have, which is teaching the network engineers and architects about the cloud technology. And then we talk about Aviatrix as well. So we have a path where we have the associate, we have the professional, which is hands-on, 3 days, in the weeds kind of a training. Then we also have the cloud ops training, which is more operations focused. This is where we discuss how to troubleshoot certain scenarios, how to look deeper into the packet, and also some Terraform and some automation angle as well.